Okay, welcome back. So I had an idea yesterday, which was that one thing that we could do in a computer algebra system is just compute group cohomology. And I'm almost sure, I mean, I haven't checked whether or not that functionality already exists in another computer algebra system. But it would be fun to try to work it out. And I've never done a lot of computations that I think you could do. So for example, I think that it should be possible to I think that it should be possible to essentially like pick an elliptic curve over some field to look at its end torsion points and to determine the module structure of those end torsion points as a Galois module, and then just determine explicitly which algebras in the Brauer group are split by those torsors for that elliptic curve, for example. That, it sounds to me, should all be computable. And so I think that that is something that I kind of want to try to do. And right, so the goal is to do it in Oscar, which is so far in my experience a Frankenstein's monster in terms of computer algebra systems. So Oscar stands for Open Source Computer Algebra Research System, and it is made up of different already computer algebra systems. So Nemo and Flint and Hecke are all systems which Oscar incorporates. Singular is another system that Oscar incorporates, and I think there's another one that I can't remember. But these are programs written in even different languages. So Singular.jl is a functionality that allows you to kind of interact with like the Singular software system. Singular itself is a C program, or it's a computer algebra system written in C. And so there are functionalities that differ between the two, but so far what I've been trying to do for this project has been to write kind of in just Nemo and Singular functionality. So for building similar algebras and central simple algebras as a data type. But I did ask someone recently who's like a maintainer for this Oscar project if I should be trying something else, specifically if I should be not making calls directly to Singular in this way, if I should try to develop within the Oscar system, and so to some extent I think this is what this is doing, but really the thing that I want to change here is I want to replace these two with just using Oscar. I'm not sure. So using Oscar. And then I'm going to see if this compiles, and I'm going to try to run some of the functions. I think that I'm going to have to change kind of a lot, honestly. But okay, and then so we'll try using Oscar and then using this package. Can't spell using correctly. And now we just try to make a call, right? So let's see what QQ is, and we'll try to make a call symbol algebra. We'll do QQ -1, QQ -1, QQ -1. and 2. So this is a data type. When I call it, it should give me essentially 3 fields. It should define a ring, which is going to be a free associative algebra. It'll define a 2-sided ideal in that ring and the degree. That's what it should do. And if I call it, it no longer works. That was not the error that I expected to get. So now what am I supposed to be doing? All right, suggestion, check for spelling errors or missing imports. I don't know how you check some things in here. So if I do type of QQ, it's QQ field. Undefined variable error, not defined in main. That was so let's try just clearing the REPL, running it again. And what we're going to be doing today is effectively, so LP ring not defined in main.csa, check for spelling errors or missing imports. So this is essentially saying that, well, before I was using just singular.jl directly. And so letter place rings, that was a type, which was totally valid. And now we need to figure out how to interact with the new system. So what's the best way to do this? It might be some reading. It might be just experimenting. So in Oscar it says abstract algebra has both commutative and non-commutative rings. Together we refer to them below as just rings. All commutative ring types in abstract algebra belong to the ring abstract type, and commutative ring elements belong to the ring element abstract type. Non-commutative ring types belong to the non-commutative ring abstract type, and their elements blah blah blah. As Julia types cannot belong to this hierarchy, we also provide the union type, which includes this, and also Julia types like integer, rational, abstract, float. So if I do like singular.freeAlgebra, QQ, I can't remember how you would do this. Okay, so I'm not sure how to call when I just have Oscar included. Actually, sorry, Oscar's not even included yet. Okay, was there a difference in the error messages? So singular not included in main, method error, no matching, free algebra. Function free algebra exists, but no method is defined for this computation of argument types. So one thing that I think I'm supposed to do in this case is I'm supposed to just do like, let's look at the libraries provided by Singular. And then I'm supposed to guess what the function free algebra is grouped under. I'm not entirely sure. So you'd think that it would be something like NCAlg, but I don't think it is. So this is why we have the source code for Singular open, and we're going to go to Gemini and just ask. Hi Gemini, where is the free algebra function defined in the Singular source code? Which library is this? so just to say I am trying to do something at the same time, we can multitask, do some parallel processing while Gemini finds us the answer. And just look up, right, like where we would think it would be. I wonder if I could search inside of a GitHub repo. Huh. So it says, so this somehow didn't help me very much, right? Kind of curious also, is there a way? So is there a way inside a GitHub repo? Using git grep. This is only if I have it stored in some accessible local file, right? The git grep command searches through the contents of files in your current working directory. But on GitHub, you can press dot in any GitHub repository to open it in an online version of VS Code. That should make searching your project very easy. Why is that not believable? That's insane that that is a feature. Hold up. Really? Will allow? So now I can search free algebra like this. And the CC came up in Dyn modules. I'm believing, I mean, I believe that Gemini is telling me the correct answer here. So why? So I'm curious. All right, I'll ask Gemini after this. So apparently it's in the free.gb, freegb.lib. A, B, C, D, E, F, G. Okay. It's typically found. Its definition within the library file is typically found under the name with free algebra with F lowercase. This library is written in Singular's own programming language. The free GB library in turn relies on blah, blah, blah. Therefore, as an aside, is there an efficient way to search a GitHub repository for a function definition? Like this case. So in here we should have free algebra. So something was deprecated. Make letter place ring deprecated. Use free algebra. Okay. So we'll try this. Singular.lib. So we'll do singular dot what would you call this? Lib free GB. And it looks like that's just it. So lib free GB dot free algebra QQ X. So now I just want to figure out, is this the syntax? And we'll also give it r comma x is equal to this. So free algebra not defined in singular free.lib. Is this one? Nope. Okay, so we can try something called source graph. Okay, so there's two things that we should do. So one, we look up source graph, GitHub, and we just see if this is like some easily accessible thing. No, we're not doing that. Okay, so then we go back here, do this. We'll try get grep in the I imagine that we could maybe run a terminal in here. So I wonder the code space. I mean, man, now I'm kind of wondering because I just selected 2 cores, so not very much needed in there. But like, GitHub code spaces, are they local? Are they free? What is this? It's a ready to go development environment for a given project, so you don't have to follow a README. We'll open code spaces. You are on our default image. It includes runtimes and tools available. Want a custom set to explore VS Code to its fullest? Search using the command palette. Command or Control Shift P. edit away. I really just wanted to try this. Get grep free algebra. So this one's an fp-adem lib. It says constructs letter place ring, but these are all defined. R and then 5 is very confusing. So let's just check. Also, that doesn't even seem like the most efficient use of a browser. So let's go here. We look up free alg. These are all examples. And honestly, yeah, I'm not even... Alright. I kind of want to say fuck that. Gemini seemed pretty convinced that it's in the free GB library. Why is that? One thing that's a little bit problematic is that I'm not sure how programs in C are even supposed to run. So undefined variable error, free algebra not defined in this library. Let's try free. I was hoping that hint, a global variable of this name also exists in singular. Alright, we gotta look at some examples to see how we're supposed to write this thing. So, if I want to call a function, I need to know what library it's in. NC tools is possibly one. Let's try that. Gemini didn't give us anything that was necessarily good. Okay, so procedures. We got gweights, weighted ring, ncond, find malgebra, write std, is central, is vile. We actually can check in the free GB. I guess what I should ask, if I was going to do this again, I would ask for procedure. So it says that make letter place ring is deprecated. And so okay, we try a new Gemini prompt. And we ask, where's the free algebra constructor procedure? we can check shit like this. That seems not helpful. We can just start trying to guess. So we got central. And Gemini comes up with free GB. Sick. So definitely there's something in here that hints at, right, deprecated. Let's see. See also. Okay, we should see this also. Maybe just letter place even. We're gonna look for all of these. fp-adim-lib. FPA props. And FP algebras. That's probably it, honestly. Crystallographic is not what you expect to see, actually. Most of the time you wouldn't click FP algebras just because, right, FP you think means finite field or something. So now the last one would be letter place, but I don't think that actually is a library. So, right, letter place, yeah. We can search for letter place. Okay. First, let's define a commutative ring, then decide what should be the degree, degree bound. Procedures. Okay, this is, I think, the most promising one. I just don't like that. All right, we're going to look for make letter place ring and see if maybe There's one more thing. I mean, this says that it's just not defined, which is like, that's the thing that's annoying. But usually, yeah, you'd have to add in a degree bound also, maybe. So let's see. Okay. So we're reading at the moment, just trying to figure out in here if there's some amount of information that can help us construct free algebras. So all constructors return a tuple consisting of a parent object R and an array of variables from which elements of the algebra can be constructed. For constructors taking an ordering, two orderings can be specified by symbol. I am hard-pressed to believe that this will give me actually an output. I'll just copy it verbatim from this, and I don't get shit, so what's going on? We're using Oscar. Oh, this is singular.jl. Right. So, right. So, fuck singular. What do we want to do? We want to use Oscar, right? This is genuinely probably different, and it's gonna blow my mind just trying to do this. That's my guess. So the Oscar type for two-sided ideals in a free associative algebra ideal, where T is an element type of the algebra. So constructors, we have ideal, free associative algebra. The real big question is, how do we construct free associative algebras? Working over field K, our focus in this chapter is on non-commutative Brodmann braces and their applications to the computational study of finally presented K algebras. At present state, Oscar offers an evolving toolkit for dealing with PVW algebras and their quotients, some functionality for computing and applying partial two-sided Brodmann braces and free associative algebra on finally many letters. In contrast to the general case of finally presented associative algebras, left-right, two-sided ideals, and PBW algebras admit finite Grosvenor basis. In particular, PBW algebras are Noetherian. The class of PBW algebras include the Weyl algebras, algebras which arise as quotients. Include Clifford algebras. Doesn't give me a lot of information on how I'm supposed to construct these using Oscar. So let's go to the source code. This is not what I was meaning when I said source code, but I'm a little bit curious. Okay, Gemini says some bullshit probably, so let's see. That actually looks promising. Okay, but then it says X and Y. No. This is an abstract algebra.generic.free associative algebra. Huh. Where's the source code for this? I mean, it's not even in here, right? Like, and it's not even in the index. I don't know if the index just shows like it's a lot of functions. I doubt that they're all called in the examples. This is the other thing that drives me absolutely nuts about this. So I'm going to spend this whole time today, I can already tell, figuring out how to just... I doubt I'm even going to figure out how to do this. So... right. Gemini says that... the free associative algebras is part of the abstract algebra package. So I just want to know, currently, ideal membership relies entirely on singular, where a degree bound is imposed and an inclusive answer may be returned. We can later add the Grosvenor basis machinery purely on the Oscar types, and hence not necessarily be confined to a degree bound. So what I want to know is let's go read. Okay, let's get rid of this. Let's get rid of all but one of these. So well, we can get rid of all of them. Okay, this is Oscar. I don't need all of the Oscars though, so we want to find out what's going on. Abstract algebra has both commutative and non-commutative rings. Together we refer to them below as rings. So it said specifically that a lot of the Julia functionality, a lot of the singular .jl functionality, so a lot of the use of singular in Oscar, it cannot function with Nemo. And let's see what that means for us. What does Nemo actually have? So it's got some useful rings. It's got some interesting field arithmetic matrices. I imagine maybe it's got some fast matrix operations. I mean, it's got the LLL method. Okay. I think it just says that that the Oscar can't use the type system of Nemo. I think is really what. I mean, who knows how big of a obstruction that is to using a lot of this functionality. Maybe I can't use p-adic fields, for example. So abstractalgebra.jl is another Julia package, and it seems like it has kind of the broadest interface for a lot of these things. So like when you call a free associative algebra, it's not clear to me whether or not that's coming from singular or whether it's coming from this abstract algebra package. So looks like so when I call a free associative algebra, I get... Actually, here's one thing that I am interested in. Can I call just like an ideal in R? Doesn't really autocomplete, but ideal of free associative algebra. Can we construct quotient? So just like R mod I. Do we need some kind of standard Grosvenor basis? So does that work? So global variable exists in statistics. It also exists in singular. It's kind of annoying, right? So let's try adding singular dot this. So no method matching iterate. Function iterate exists. That actually doesn't make any sense to me, by the way. We're going to pass on that for a second, because we don't know how any of this stuff is being constructed, so... So this was something that I was annoyed by when I started doing this, and why I was kind of happy when I got things working inside Singular.jl. And the annoyance was specifically that there's some free algebras defined in abstract algebra, and there were also free algebras defined in Singular. But getting those two objects to interact with each other is very much not clear to me. Not clear how you do that. So this function is totally valid, right? That's what we've seen so far. So we get functions. If we want to use this free associative algebra functionality, we get functions symbols, number of variables, gens, gen, is gen, total degree, length. Leading coefficient, leading monomial, leading term, leading exponent word, coefficient monomial term. Maybe even evaluate. Function Grosvenor basis provides the computation of Grosvenor basis of an ideal given a set of generators for that ideal. Okay, let's try that. So what's the type of J? Ideal gens? What's the type of I? So can we redefine J as being ideal J? Okay, now can we do quotient? All right, so okay, so this did work with Nemo and Singular. So we're not going to change anything just yet. I want this to be usable in Oscar, but it's not at the moment. And Oscar is confusing as fuck. So let's see. So Gemini tells me that I can just do something like Q pi is quo R and J. And that's not true. And the closest candidates are finite generated abelian groups and Hecke. I mean, I'm not trying to do that, so let's see. So PB Algebra Quo, developer doc. The revised code allows two slightly different implementations. Original implementation, where PBW Quo Elem is just a PBW Elem with a simple, almost transparent wrapper. All arithmetic is delegated to the PBW Hence, values are not automatically reduced after multiplication. Which is fucking super annoying, right? I mean, like... Is this... I can't tell if this is a normal thing to expect. So, NC polynomial has a data REPR. I can't understand what that... repository? I don't know. Representation. Has a data representation, which is compatible with the overlying singular PBW alg, so may be operated upon also by that ring. The singular representation is then wrapped into an Oscar PBW alg elem, which also contains a parent reference to the Oscar object representing the PBW alg. This PBW alg elem is wrapped once again. I mean, is that normal? So the exercise is sit down and draw a box and arrow diagram of values and references. Is this a normal way to develop, though? It feels like to me it's just so fucked up. And I get that I could be inexperienced in this way, so... little bit overwhelmed. I'm not gonna lie. So this is just me thinking, right? Like, right. So here's just wrappers for gap. So I don't know how the gap language works, but one of the things that I want to do, because I think that you should be able to compute group cohomology, is like have a way to represent groups. And then basically you also want a way to represent group modules or modules under the group ring. And if you have finite groups and finite modules, then it should be possible to compute cohomology very easily. And gap is definitely, right, the way to go when it comes to computing using groups, just because of probably how long it's been available. You'd think that it has probably all of the functionality that you could possibly ask for, probably more than you'd even want. And so I'm just wondering, whoa, Chacho. Can I do just like a Abelian group? I'm wondering if I call a Abelian group and just like AB. I want to know just what kind of error am I going to get. So not defined in main was kind of how I thought that it would be, right? So if I do gap wrap Abelian group AB, now I should have some crap or what? So question, Abelian group. Search, Abelian group, Abelian groups, free Abelian group, Abelian closure. Could not find, but you can find Abelian group, huh? Whoa. Trying to pull a fast one on me. Yeah, what's that about? What's that about? I don't think I understand why, for example, they have quotients for PBW algebras and not for general non-commutative algebras. And I don't understand why there's functionality in singular for quotients, and in Oscar it's seemingly not immediate. I don't understand anything about what is available and what is not available. Okay, so I guess I'm just confused. So I'm just confused in the sense that it seems like, so what we should be doing is relying on just this. And honestly, I think I'm just going to forget about the other stuff, act like it doesn't exist. I'm kind of interested in just this question. So, at the moment, it seems like you could construct quotients of PBW algebras, and you cannot construct quotients of general free algebras. And so what is the purpose in having that differentiation between the two, right? You'd think that to some extent you would want a non-commutative ring type, which when you call like quotient on any pair of a non-commutative ring and an ideal, it will give you another non-commutative ring. And I guess the issue is that there's no way to descend the type in Julia. Is that true? So like if I have, let's say I have a rational number, and an integer is a rational number. So I could start with an int, and if I promoted that to a rational, then there's no way to go back, I guess. Is that true? Let's ask Gemini. So we're gonna go new chat. It's going to say no, and that's going to be problematic, is what I'm thinking. Oh. You can convert the type. Yeah, okay, then what's the fucking point of having this? Why wouldn't you just have PBW algebras being a subset of non-commutative rings, have a way to quotient non-commutative rings? Is the issue that there's no canonical way to do that? Like, this could be genuinely because of this note, essentially. Quotients of PBW algebras, modules, two-sided ideals are also known as GR algebras. Here, GR stands for Grosvenor ready. So maybe what does it mean to take quotients? The example above shows one way of constructing the exterior algebra. For reasons of efficiency, it is recommended to use the built-in constructor exterior algebra when working with exterior algebras in Oscar. So let's just ask again. Is there a reason why there are well-defined quotients of PBW algebras in Oscar, but not of general free associative algebras? Let's see what a PBW algebra even is precisely. So for general ideal in a free associative algebra, a finite Grosvenor basis may not even exist. Sure. The algorithms to compute them, such as Buchberger's algorithm, adapted to the non-commutative case, are not guaranteed to terminate. This makes it impossible to create a general-purpose reliable function for computing quotients of any free associative algebra. Yeah, so it all right. So it doesn't seem all right. So okadoke. All right, so we could totally do this, but I think that we have to call certain things in order to get like. Okay, so I just have to lock in and try to figure out how to get some of the singular functionality into Oscar. Or just write it myself. What sounds more fun? So this was not the worst to do. I think what I'm going to do is write the functionality myself, I guess. So let's see how the PBW quo functions are operating. I mean, does it matter? Okay. All right, I think I can do this. So we'll use the underlying functionality of free associative algebras, and we'll define a central symbol algebra, and it will have operations that we can define, and they will just call reduce a bunch, I think. Maybe. Is that the way that the data type should go? Maybe. I think I'm gonna start dinner, so I think I'm gonna stop streaming, and then I'll start again maybe later tonight.